Okay, so like I said, we've covered the graphical user interface. What we're looking at, this is the graphical user interface, and I would just quickly go over those parts. This guy over here, this guy is called your quick access toolbar, our quick access menu. It primarily is file handling: new, open, save, save as, import, export. This guy, I'm sorry, that was the application menu. This is the quick access toolbar, excuse me. And it basically has the same thing that's in the application menu. We have up here, that's your title bar, and then we have the info center. The main action location of your menus are down here in this guy called the ribbon. The ribbon is broken up into tabs, and then each tab is broken up into panels. So we have, like in this case, under the Home tab, we have the Draw panel, the Modify panel, Annotation panel. And we're going to spend the majority of the time in that Home tab. And in fact, today we're going to work almost extensively or exclusively with this Draw panel and some of the stuff up here. Okay. This area is your graphics screen, and that's where pretty much all your action happens. And you can think of it as a digital piece of paper if you want. That's a good way of looking at that.
Hey, I'll be right back. I have
Okay.
to do it late apparently, so I
All
can't
right,
get into it. I'll be
no
back in
problem.
like 2 or 3 minutes.
Okay, no problem. So this is your view cube, and that's for zooming it, or not zooming, but it's for looking at views differently than, say, plan view. For everything that we're going to be doing, primarily we're going to want to lock it into that top view. So kind of just stay away from that for now, because you can kind of mess yourself up sometimes. Over here, this is called the UCS icon, and this is showing us the direction of positive X space, positive Y space, and remember, due to right-hand rule, the Z, positive Z is coming right at us, okay, as you sit and look at this. And then the other big area is this guy here. This is called your command line or command window. Some of you guys have it undocked. If you like it docked, you can click on those guys. That's an undocked position. I like mine docked down at the bottom, and it just keeps it, for me, it's a lot simpler to use, okay? And in this area over here, this is called our status bar. And the status bar has things like on and off settings. So for your grids and those kind of things, okay? So that's our graphical user interface. So we did talk about what an object is. All of these guys primarily over here are little object critters, and they all have names. They have properties that we'll be looking at. But today we're going to we looked at the line the other day, so we're going to pick up with circle, arc, and rectangle. And then we're going to get into the polyline and some of these other ones. Okay, so we're going to primarily be working with objects today. And these first, I mean, you're always working with objects when you're in AutoCAD, but we're going to understand those a whole lot better. And then we've got the coordinate systems that we're going to look at. That first couple of labs, you're going to be dealing with coordinates. And again, probably when I turn you loose and you guys start playing with this, you're going to have questions. I guarantee it. So that's where Wednesday will really kick in, and we'll be able to answer any type of question that you have based on that. Okay, does anybody have any questions on anything that I discussed there before we move on?
Nope.
Okay. All right, so we took a look at the line command. We find the line up here. Remember, if you click on that object or that tool, you can generate a line just by picking a point, picking another point, picking a point, and then it does have sub options such as close or undo. Okay, so this is one of your most basic primitive type of objects. Okay, so I want to now take a look at the circle command. That's another primitive object that you use, but it does have quite a few sub options. So I'm going to go ahead. If you drew a line like I did, what I'm going to do is just delete them. Here's an easy way to delete. I didn't show you this before, but you can just click on the objects that you want to delete, and then on your keyboard you can hit the delete key. So that'll take things out. Okay. So let's look at a circle. So a circle, again, very basic object. It's used a lot in AutoCAD. It has what we call sub-options associated with it. So the circle is up here in the Home tab, Draw panel. Click on that, it drops down. These guys are sub-options of ways to create circles. So you have what's called a center radius option, a center diameter option. You have a 2-point, which is basically defining 2 points on a diameter, essentially. And then you have what's called a 3-point option, which is actually a really cool option. So it allows you to pick 3 points uniquely. Unless they're in a straight line, it won't work. But any 3 points that aren't in a straight line, and it'll pass a circle through that. So what it has to do when it does a 3-point, it has to calculate the radius that can achieve that, and it also has to determine for you the center point. So that's a really neat one. Then we have this guy called tangent radius, or they call it TTR sometimes. So this allows you to select 2 objects, and it'll automatically make that circle tangent to both those objects. So there's a lot of math going on some of these. And then the last one here is called a tan circle. And what that really is a 3-point circle, but it has the other condition that the objects are going to be, or the circle is going to be tangent to 3 objects that you select. Okay. So what we're going to do is first just do a center radius. It's the most basic. So we just go up here and we click center radius. And what it's going to do is ask you to specify a center point of your circle. So you can just pick a point. Now, of course, we could use coordinates exactly. So if I wanted to be, let's say at 2,3, I could type that in. I'm just eyeballing it for right now. So I'm picking a point by left clicking. And notice as I drag my cursor out, it's asking me to define the size of the radius. And again, I can do it by just dragging it out and clicking it. That's called eyeballing. Or I can give it an exact value. So if I want to say, well, I want my radius to be exactly 2 units or 5 units, I'm going to say 2 and hit enter. My circle is now exactly a radius of 2 units big. Okay. So that's probably one of the more common ways of defining circles, because we usually know the center point of that circle, and then we usually know either the radius or the diameter. Okay, so let's try the next option. The next option is circle diameter. So it's essentially the same thing. It's just got a different parameter. So when I pick the center point, diameter, I just pick a point where I want it to be. Now you'll notice if you look down in the command line, now there's a value down there. And that value is placed in there based on the last circle that I created. So it remembers the last circle, and it's assuming that I might want to use that same value. So if I do want to use it, I just have to hit the enter key or the space bar, and it'll accept that. If I don't want to use it, then I can overwrite that. So for instance, if I type in 4, or let's say 2 for the diameter, then what I have is a different value circle. So it's kind of neat because it will remember things from point to point, what you've got. Okay, so circle center point radius and center point diameter, they're essentially the same way with just a little bit different parameters. Okay, everybody okay with that?
Yep.
Okay, so we'll move on. Here we have what's called a 2-point circle. So you're not probably going to use the 2-point circle quite as much. But what it does is it defines when you pick 2 points. So if I pick a point here, think of it kind of like it stuck a pin at that point and it holds that fixed. And as I drag this out, what I'm actually doing is dragging the location of the diameter from the first point to the second point. So what will happen with this, the diameter is going to be referenced between the 2 points, and the center of it will be in the middle of those 2 points. So in this case, you don't necessarily know where the actual center of that circle is, as opposed to the way we just did it. Okay, so if I drag this point out there, what that did was that created that circle based on 2 points along it. Okay, and again, what you're really defining there with those 2 points is a diameter. I don't use this anywhere near as much as I use this, so probably, let's say if I'm using circles, 80% of the time I'm either doing a center radius or center diameter kind of circle. But Not to say that this one isn't valuable. It definitely is. They all are really good options. Okay, so let's look at 3-point. And 3-point is really very powerful. Like I said, all it's going to do is calculate for you the location of the circle and also the radius that it needs to pass it through 3 unique points. So if I go to circle 3-point, now I'm just eyeballing points. So if I have a first point and a second point, and notice the minute those 2 points again act kind of like fixed locations. You can't really see them, but they are fixed in space. And then the third point will define really where that circle is going to be in terms of its center point and its radius. So once I do that, then I got that in. Now all of these objects that you see here are really truly the same type of circle. They were just created differently. Okay, so if you list these objects, all it's going to do is it's going to tell you it's a circle. It's not going to tell you how it was created. Okay. So this one, 3-point, it's a great command, particularly as a surveyor in the business. A lot of times I would use that command because if we were locating, let's say, a big tank, like I'm sure you guys have seen those big tanks along the river where they store gas or petroleum products or whatever, we would have to sometimes locate the center of those tanks, and you're obviously not going to be able to climb down in them and get a center point. So what we would do is we would locate 3 points along this thing somewhere, and we could calculate the center of that by doing that. So it's a really, really powerful option. All right, so I'm going to show you this one. This was called tangent radius, and this one is actually really, really neat. You can do it with a lot of different types of objects that are out there. If you're following along with me, what I'm going to do is just draw, let's say, a line like this. I'm just eyeballing a line in, and I'm going to eyeball another line down, and then I'm just going to go ahead and hit enter. Okay, so I can be tangent to most objects that can have tangency. Things like lines, polylines, circles, arcs, rectangles. Most of these things can be used as tangent objects. There's a few objects that are unique that won't reference that, and one of those is what's called a point, which we're going to take a look at today. So when I have 2 objects like this, I can be tangent to either one of these. So what I'm going to do is just go in here and do a tan radius. And what it's going to ask me to do is specify point on object for the first tangent of circle. So all it's really asking me to do is select this object, and it doesn't matter where you select it. But when you bring your cursor up, you'll notice you get that little green symbol. It's a tangent symbol, and it says it's a deferred tangent. So what that means is you're going to pick the object, but then it's going to need another object. So I'm just going to click this object. I'm going to click it anywhere. And then it wants me to select a second object to be tangent to. So now it knows those 2 objects are the objects that I desire to use. So now it needs to know a radius. And the radius, again, is up to whatever value you want that radius to be. So I'm going to type in 2 and hit enter. And you'll notice what it did is it put my circle in there, and it's tangent to both objects. And I'm assuming everybody knows what tangent means. Does anybody not know what tangent means? Or can tell me what tangent means? Anybody tell me what tangent means mathematically?
Oh, mathematically, I don't know, but tangent, tangent, I would have to say like, doesn't it mean that well, like it's correlating or just, I guess, identical to the other object or?
No, no. What it means is that, and this is really important, so what it means is that this circle at this point over here is touching that line only in one spot, okay? So for instance, let me show you what I mean by that. If I take this line and swing it in like that, that line is no longer tangent to that circle because it's running through that circle in 2 spots. You see that? And when you come through a circle in 2 spots, that's called a secant location. So tangent is unique. If I zoom up over here, there is only one unique spot where that line is touching that circle, okay? So that's what that tangency means. That's why it's such an important feature, okay? All right, so again, if I look back at that, this is tangent now to both of those objects. That's why that's so powerful. And again, I could do this, if I wanted to do this again, tangent, tangent, radius, I could be tangent to this object and tangent to that circle. And again, all I have to do is supply the radius, let's say 3, and notice what that's done is now tangent, this circle is tangent to that circle and tangent to that line. And again, that's a really highly important principle, because what that does is make sure that we are touching uniquely in one spot. Okay, is everybody okay with that? It's a lot of math going on right there to make that happen. All right, so I'm going to show you what 3-point tangent does. So if we come up here, I'm going to draw a line like this. So let's say we want to put a circle that is going to be tangent to each of these lines, okay? We can do that. You could use the 3-point option, okay? But you would also have to tell it that you want to be tangent. So they have a built-in tangency, which is called tangent, tangent, tangent. So if you select that, you just pick the first line, pick the second line, and pick the third line, and notice it automatically puts it in. So I don't even have to supply radius or any of that, because it goes in and calculates my radius, and it also calculates my center point. So that's a really, really powerful group of commands. All right, does anybody have any questions on any of those? We're going to be utilizing those, circles off and on. So you're going to see the line and the circle are 2 of your commonest objects, the most common that you'll see. No questions?
Nope.
All right. If you're following along with me, what I would suggest is we'll just go ahead and clean the screen up, because I want to take a look at some other aspects. So I'm going to just do an erase. So I'm just going to type in E and hit enter. And then we're going to type in the word all, A-L-L, and hit enter twice, and that'll take everything out. Okay. All right. So we're going to take a look at the rectangle command. And the rectangle's somewhat of a unique object. So the name of the command, by the way, is rectang. Okay, R-E-C-T-A-N-G. Even though if you go click up here, and this is the actual command right there, that's the rectangle command. Notice when you put your cursor up there, it says rectangle, but down below it says rectang, and that's the actual name of the command. And it used to be that a while ago, and actually maybe even as much as 3 or 4 years ago, if you typed in the word rectangle, it told you unknown command. And so they've actually aliased this command rectang to recognize rectangle. So people, because I think people got frustrated, they were trying to type in that and it didn't work. So the rectangle is a very unique object. It looks like 4 lines essentially, but it actually is just one line or one object, if you will. And this is because this is an object called a polyline or a P-line. So we're going to look at this P-line object a little bit later, but this is a type of polyline. So this is very simple, although it does have some sub-options. So when we click on this, basically you'll notice at the bottom there are sub-options. You have a sub-option chamfer, you have a sub-option elevation, fillet, thickness, and width. So I'm going to show you how some of these work, and some of these things are unique to polylines, and that's why we're seeing them here. But by and large, all we need to do is define 2 corners of a rectangle diagonally. So if you're following along with me, you can just pick a lower left, and then you can pick an upper right, and you notice that's all there is to it. So I just picked the lower left, upper right. I could pick that to that. So I could go any way diagonally. So if you get your rectangle in, one of the things you'll notice is when you click on this object, it's not 4 objects, it's just one object. And that's because, again, this object is really not a rectangle. It's what they call a polyline. So if I listed this object, it wouldn't tell me it's a rectangle, okay? So because it's a polyline, there are some other things we can do to this. One of these things is to give this guy width. Now, the way width works on a polyline is it's going to take and use this as the skeleton, and it pulls the object out this way, and it'll pull the object out that way. So think about that as a framework or a skeleton, and just it kind of pulls it out. Now, the one thing to understand with this width is that it really only looks or exists graphically. It doesn't exist realistically. So in other words, there is no edge on the width. It's just there graphically. And you can also turn the filled in width off so you can see two parallel lines if you want. So I'm going to show you kind of how to do that. All right, so we're going to go in and we're going to define a rectangle. So I'm going to go into rectangle. And before we pick two corners, what we have to do is define the width. So you notice down here there's a width option. And you can either type in W and hit enter or just click on the word width. Okay. So this width, by the way, is equidistant. So when it comes out, if you tell it the width is let's say 2, it'll be 0.1 in this direction and 0.1 in this direction. So the actual points that you select on this are going to be embedded inside of it. Okay. So don't make this too big. If you're following with me, I'm going to make this maybe 0.25. Okay, 0.25. All right, so now that I've got a width set, I'm going to pick a point, and I'm going to pick another point. And you'll notice, if you notice, the look of this is different than this because this actually has a width associated with it. And when I click on this, notice if you see these little blue boxes, this is actually where the actual geometry mark is. So this is the edge of the width, left and right, or top and bottom, however you want to look at it. This edge really doesn't exist. Okay, it's just the way it looks. Does everybody see how that's the difference between these two? So if I take this object and turn it into a non-polyline, it will lose the width. So what I'm going to do is select this, and I'm going to come up here and do what's called explode. So I'm going to go ahead and explode this guy. And you'll notice when I do that, what that does is it blows the polyline apart. So it loses the width, and also notice it's no longer one object. It's now 1, 2, 3, 4. So what it did is it broke it down into lines by doing that. Okay. Any questions? By the way, you're probably not going to use a polygon or a polyline, I'm sorry, a rectangle all that much, but we'll use it for a few things. It's nice for doing borders and those kind of things. Okay, so let's look at some of the other options here. I'm going to take this width. My width was a little small. I'm going to beef that up just a little bit. So if you want to beef your width up, if you're following along, I'm going to maybe make that about 0.4. And the other two things we're going to look at, one is called fillet, and the other one is what we call a chamfer. So a fillet is where you take this corner and you round it off with an arc. Okay, so we give it an arc radius and it's just going to round it, which is a very common thing. So we're going to do a fillet first. And what it wants to know is what radius value you want. So if you have a 0 radius on a fillet, you're just getting a sharp corner such as this. Okay. If we get it, let's say put a value of maybe 1 in there. When I pick 2 points, if you make your rectangle big enough, notice what's going to happen. It's going to round that corner off. And also because I have width turned on, I'm giving a width rectangle that has filleted corners. And so this guy right here is called a fillet. And that's a very common property. In fact, there's a command up here called fillet, which we'll be talking about in a couple of weeks. So this one's used a lot when you do drafting and CAD work and that kind of stuff. But this has the built-in fillet. And the thing is that when you actually create this, the fillet will have the same radius value for each of the corners. Okay. So if I would explode this polyline, I'm going to get back 4 lines and 4 arcs. That's what it'll give me. Okay. Any questions? Okay, one more thing to look at is what's called a chamfer. So a chamfer, instead of putting an arc at the corner, what it'll do is it'll put a straight line. It cuts it off with a corner edge. So it's, instead of doing the arc, it's kind of doing what you might call a chord of that. So when I go to chamfer, what it's going to want to know is 2 distances. So you can come a distance down this way, and you can come a distance over this way, and they don't have to be the same distance. So those distances can be separate and different. If you typically do the same distance, then you're going to get a 45-degree chamfer. So I'm going to just make my chamfer distances the same. I'm going to make them a little bigger, maybe 2 inches, and 2 inches for the second one. So this time now, when I create a chamfer rectangle, okay, that's what we're looking at. So this is a chamfer, this is a fillet, and this is nothing going on there. Okay. So the rectangle can do very simple. It can have width, it can have fillets, it can have width with chamfers, you can have no width. And because this object is a P-line, there's going to be other ways to edit it later on. Any questions anybody has? So I do want to show you something here, and you guys don't need to do this, but I just wanted to show you. Notice the width shows up here really readily, and that's because we're looking down on this in plan view. If I pop this into a different view, you notice that we lose the width, and that's because we're not quite looking down in plan view. And really, I don't even have to be off that much. I can be pretty close to plan view, but not all the way. And if I'm not exactly, it looks like I'm in plan view right there, but I'm not actually in plan view. And so I'm still not getting my solid lines. So one of the things I told you guys to remember is really kind of stay away from this, because this is the kind of stuff that it can do to you. And the easiest way to make sure that's good over here, if it says custom view, you're not in a true top. So notice when I go to a true top, that takes it and fixes it. Okay. Any questions on that you can think of? Okay, so we're going to be, on this first assignment that we're going to be getting into, we're going to be utilizing these 4 objects: line, circle, rectangle, and then the last object we're going to take a look at is an arc. Now, by far, this is one of the hardest objects to use in AutoCAD, and so it's not very friendly either. I want to show you a couple of things about arcs that you may or may not be aware of. So I'm going to flip over to this little tool here. So this is my whiteboard, essentially. So let me draw an arc. I think I can draw an arc pretty well using this tool. Okay, so that's not quite an arc, but it's close. So what I'm going to do also then is see if I can draw a line. So I'm just approximating an arc. You're going to get a true arc when you do it in AutoCAD. So if you're not used to arcs, they have, there's a lot of terminology, and basically to define a circle, you only need 2 points, or two parameters, let's say that, not necessarily points, but 2 parameters. You need a center point and you need a radius. I mean, that's all it takes. But for an arc, you've got to have 3 points, or 3 parameters. So there are quite a few things about arcs, and actually there's like 7 or 8 different ways to create an arc. So that makes it really confusing. So if I, let me do one more line in here. Okay, so as we get into this, let me take a look at this. So the first point we're doing is this guy right here to here to here. Okay, so this guy is called your start point. This guy is called your end point. And this guy is called your center point. So your S is equal to start. Your E references end. And C references center. So all of these guys are dealing with coordinates. XY, XY, XY. And by the way, the Z's have to be the same because this guy's a coplanar object. So I won't even talk about Z's because we're assuming that everything's on the Z plane. So this is a three points, and notice also the arc always wants to draw counterclockwise from the start point to the end point. So that's important to understand because it's going to want to go like this in that direction. Okay. If you flip, if this is my start point and that's my end point, I'm going to get the arc that's going to go this way because it always is going to go from the start point to the end point counterclockwise. Again, that's also because of right-hand rule. All right, so you also have this guy right here, which we'll define as R, and this is R. That's a distance, and R would stand for radius. And one of the things I think most people know, but you should know if you don't know it, that from the distance from the center point to any point on the arc is the same value. So from here to here, it's radius, here to here, it's radius, here to the end, here to the start, it's always the radius. So this is a distance. So notice these are coordinates, this is a distance. You also have this guy, which is called the included angle. I think they just call it A, but this is the included angle. And you can turn it clockwise, which would be a positive included angle, or you could turn it negative, which would be an angle like that. That would be a clockwise rather. This is counterclockwise. Okay, so you have to kind of watch that. So that's an angle value. They also have, if I drew a distance from the start point to the end point, that's what we call a chord of an arc. And they define that as L. Whoops, let me undo that. So this is what's defined as L, and that's your chord. And that's also a distance. So this is a distance, that's an angle, and those are coordinates. So we have 1, 2, 3, 4, 5, 6. There's another thing in here called a direction. So this is the direction that that thing is coming from. So you need 3 valid things to create an arc, okay? So I could use a start, center, end arc. I could use, let's say, a start, center, angle arc. There's a lot of different options. But for instance, if you don't have 3 unique points, you won't have a valid arc. So for instance, if I tried to do a start, center point, radius arc, that wouldn't be enough information because the distance from the start point to the center point is the same thing as the radius. So that wouldn't work. Okay.
Jim?
Yes.
I'm a little uncertain from a mathematical context what the direction is or how that is actually related to the arc.
Oh, okay. I forgot to mention that. This guy here.
Yeah.
Yeah. So what this is, if you're constructing a line here and you're coming off of that arc, it knows this direction on that line, and what it'll do is this right here, I think it forces it 90 degrees right there.
Okay.
That's called a tangent arc, okay? Now, that's the problem with drawing this arc object, is that if you don't do this right, you don't necessarily get tangent arcs. And if you don't get this object and this arc tangent to each other, you're going to be slightly off on things. That's what, trust me, for one thing, this command is really hard to use. I mean, I design and develop things with arcs all the time, but I would not use this command to do it. There's a
Okay,
lot better. There's a lot better ways of doing it. Okay.
Yeah.
One of the things you're going to find we're going to do a lot, because we can make lines and objects tangent to circles so much easier. What we'll tend to do is use circles and then just trim them. Okay. So in about probably like maybe next week even, we're not even going to use this command anymore. Okay, we'll pretty much throw it out the window. Okay, I just want you to use it. I think I'm having to use it on this first assignment, but other than that, it's not that big of a deal. Okay. Well, the other thing that's helpful with the arc is that AutoCAD will prompt you, or it kind of shows you what's a valid option. Let's jump over to AutoCAD real quick and I'll show you what I mean. So if we go back over to AutoCAD, let me just minimize that. All right, I'm going to clean this screen up. And I hope I answered your question, by the way, Nate.
Yeah, thanks.
Okay. All right. So if we look at the ARC options here, they only give you options that are valid, which is the good news. Okay. So they have what's called a 3-point, which is basically a start point, a point on the arc, and an end point. So you don't use that too much because you don't have a lot of control. The arcs that you have the most control over are the ones that we see down here. So start, center, end, start, center, angle, start, center, length, those kind of things. Okay. So let me do something here. Let me come back to this picture, and then we're gonna try some. I'm gonna erase this a minute. Let's just kill this. Let's just do no. So let me see if I can get a nice arc here. Let's see. So let's say I wanted to construct an arc like this, and let's say I know some coordinates. Let me, let's see, I'm going to put a line in here and I know here. So let's say I have this coordinate right here. So I'm going to call this 2, 2. And we're going to assume this line is straight up in the y direction and this line is straight over in the x. So can you tell me what this angle here is, anybody? So if this is parallel with y and this is parallel with x, what would this angle be here?
90.
Yes, so this is a 90 degrees. So we know that the included angle in this arc is 90 degrees. Now that's, again, that's not always true. In fact, a lot of times it's not, but we're going to assume that. And we also know, let's just to keep this simple, let's just assume that this radius on this guy, r, is equal to 2 inches or 2 units. Okay, so we know 2, 2 is our starting point. We know the radius is 2, and we know that this is 90. So by knowing that, I can tell you we could do a start, center, end arc really easily, or we could do a start, center, angle arc really easily. Okay, so I'm going to go back over here to AutoCAD. Let's pull up AutoCAD. And what we're going to do is go into the arc command. And what I'm going to do is what's called a start, center, end. Now keep in mind, I know the start point. So I'm saying my start point is at 2, 2. All right. So notice what it's doing is it's flipping me in right there. We need to go up straight 2 units. So here's where I'm going to use a coordinate. I'm going to say I want to go 0 in the x and 2 units in the y because I want to travel along the y-axis straight up 2, and I'm going 2 from the point I came from. That's what the @'s saying. So now I'm sitting at the center, and now it needs to know the end point. And so the end point would be at 2, 0. And by doing that, there's my start point, my center point, and my end point. So I had to do quite a bit to make that happen. You guys agree? And I had to understand what I was using there. Does everybody see that?
Yeah.
So the thing is that arcs are going to be, yeah, they're going to be a little tricky. I'm going to show you some tricks about them. Let's go back to this picture here. So let's assume, basically, let me just kill this a minute.
Well, I have a question.
Yeah.
Once you know, if you have the two lines already, and it's asking for the degree, can't you just type in the degree in for what you want the degree for the arc, and it'll just like say you select arc and then you put the degree of what you want, and it'll just do it? Or...
Well, let me draw it on here a minute, because I think I know what you're saying, but I just want to verify it, okay? Are you saying you have a line that's coming in, right?
Mm-hmm.
And a line going out? Is that what you said?
Yeah.
Okay. So if these lines, notice this line is not parallel with X. So that already complicates how that arc's going to work for you. Okay. Does that make sense?
Yeah.
Unless you know what this angle is, and you can use direction command to do that, but I still have to like pick the two endpoints of that line to show AutoCAD what that direction is. It really makes it tough. Okay?
Oh, okay. I see what you're saying now.
I'm not saying that there's not easier ways to do the arc, but right now we don't know how to do that. Let's put it that way. Okay, does that make sense?
Yeah.
Okay, so if you have anything other than parallel with X and parallel with Y, it just makes arcs pretty difficult. Okay, but I'm gonna show you something here. Let me see if I can get this. Give me a sec here to draw something. This little tool, by the way, this is actually a really cool tool. This is an AutoCAD program, actually. It's or an Autodesk program. So let's say we have an arc there, and I'm gonna, let's see, go into this guy. Okay, that's my supposed arc. It's not perfect. And so I'm going to assume that these guys are like tangent. Okay, this is much easier to do in school on the board, but I'm going to say that we're going to start out here at 2,2, and we're going to go 3 units to get to this arc. And we're going to know that this arc is, again, we're going to say that the radius is 2 units, okay, and that this is 90 degrees. And then we're going to go up 3 units. Okay, again, so we're going to start at 2, 2. We're going to go 3 units. We're going to hit this arc. Then we're going to go up and over just like I did before. And then we're going to go up 3 units. And if we want, we could attach an arc at the end. Okay, is everybody with me on that? So I'm going to do this on the screen, show you. So I'm going to go ahead and delete this arc, and if you want to follow along with me, that would be great. So I'm going to start out with my line, and I'm going to type in 2, 2, because that's what I knew that my starting point was, okay? And I said that this line was 2 units long. So I'm going to just say 3 units, excuse me, I think we said 3. So I'm going to say 3 in the X, 0 in the Y. Okay, so there's my line. I'm just going to go ahead and hit enter. So now if I look back at my picture, I just constructed the line from 2, 2 over to here, and the coordinate of that point actually would be at, 5, 2, right? Because 2 plus 3 gives me 5, and the 2 is the same. All right, so we're back at AutoCAD, and I want to do an arc now. So what I can do, because I know all the information, I can do another center, a start, center, end. So my start point we just said was 5, 2. I'm going to do my 5, 2 and hit enter. And I know that, again, I know I'm going straight up 2 units, so I can say at 0 in the X, comma 2 in the y. Takes me to the center point. And I'm going to come over at 2 in the x, comma 0 in the y. And there's my arc. So that wasn't too bad. Now, here's the thing. I want to attach this line to this arc tangently. So in other words, I want it to go straight up, and I want it to go 3 units. I'm going to show you a little trick. We could figure out this coordinate and do it with coordinates. And we know this is 5, 2. So this would be 5, comma 4. So this would be 7, comma 4. So the coordinate of this is actually 7, comma 4. Everybody see how I got that? 5 plus 2 gives me the 7 in the whoops. I think I did that backwards, didn't I? Check that again. Oh no, I was right. This is going to be 5, comma 4 here. So that makes that 7, 4. So that was correct. Okay, so I could use coordinates, but that just makes me have to deal with a lot of math. I'm going to show you this little trick that you can use with arcs. So back to AutoCAD. In AutoCAD line, when you go to the line command, I could type in the coordinate of that, but there's what's called the arc line continuation. So when it asks me to specify this first point, all I have to do is hit enter. And it automatically attaches the line to the arc, and it shoots it off in the direction that it needs to tangentially. So all it needs to know now is the length. And in this case, I just want that to be 3 units. And then there it is. So that might be kind of what you were talking about in terms of doing that arc, but it's going to take you a little bit of time to get using arcs, and the reality is we're not going to use them all that much. Okay, that's the good news. So we will be able to dispense with them a little bit. Okay. Anybody have a question? Did I just blow you guys away? Hopefully not. Everybody okay? Is anybody still there?
Yep.
My question is not specific to this, but I forget my cursor. I've got the setting accidentally turned on where my cursor keeps messing up my coordinates. I can't remember which box it is.
Okay, good question. All right, down here in the status bar, okay, you have a bunch of little tools, right?
Yeah.
There should be one that looks like this. It's got a plus and a little box next to it, and if you put your cursor on it, it should say dynamic input. See if you can find that down there. You may not have it turned on, so I'll show you how to turn it on if you don't have that turned on. Are you finding that? I'm assuming it's probably turned off. So let's go over here. Notice this 3 stacks of paper, I call it. That's your customization tool. So click on that, and it'll open up this guy right here. So you're looking for one that's called dynamic input. Should be at the top. You finding that?
Yeah, and it should be off.
Well, turn it on so you can see the button. Okay, you see the button now down there?
Yeah.
Okay, now it's blue, right?
Yeah.
Click on it and that'll turn it off.
Well, it was off before, so that wasn't what was messing me up.
Oh, really? It was off before?
Yeah, but it's okay. Just keep going. Don't.
Yeah, it should. You were getting the information up at the cursor. Is that what was happening?
I don't know what it is. I just know I'm having trouble using the line function.
Okay.
But don't worry about it.
Well, I'll tell you what, write some stuff down, and then this is stuff that we can handle on Wednesday if it becomes a real issue, okay?
Yeah, I can figure it out. It's fine.
Okay, but I think it sounds like that tool was turned on. You know, that's what it sounds like. So if it's turned off now, though, that's what you want really, because what it does is a lot of times when you're trying to do relative coordinates, it overrides them. Okay, and that's what the issue is very often. Okay. Anybody else questions? Okay, so I'm going to go over. That was basically everything we wanted to do in that first week. Okay, so I want to talk about P-line, polygon, point, donut. So these are also draw commands. And we'll see how far we get with those. And if we get a little bit further, I'll probably go over the first assignment so you guys can kind of start trying it. And I'll show you how to do the, if we get time today, we'll take a look at file commands and those kind of things and the views, but I just, you know, I don't know how long we're gonna go. So, all right, so the polyline command, we already took a look at in terms of the rectangle, but I just want to show you kind of some of the differences that it has. So if you have stuff on your screen, what you might want to do is go ahead and clear it up. So I'm going to just type erase for E, and then select objects by typing in the word all, and hit enter, and enter twice. So by the way, what I'm doing is doing a mass erase on your whole drawing by doing that. And obviously that's not something you would want to do most of the time in the real world, because what you're doing is erasing everything. So if you had a drawing out there, you're taking everything out. So we don't normally do that, but for what we're doing, just demo, it's a good way of cleaning up your screen. Okay. All right, so let's take a look at a polyline. So this is your polyline command, and it's right next to the line. And by the way, they show you polyline, but it actually can be two types of objects. You can have a line or you can have an arc. So you could have polyline or polyarc, but basically it's just arcs and lines that function as one object. So that's just the best way of thinking of them. Now I want to show you something, that if we have a polyline right next to a line, you really can't tell the difference on the screen. So here's what I'm going to have you do. Just go to the line command, and you're just going to eyeball a point, pick, 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 and pick like that, okay? So we have 1, 2, 3 lines. And I'm going to want you to do the same thing in the polyline for me. Don't worry about just looking at what it says. Just pick on the polyline, and you're just going to pick a point, pick a point, pick a point, and then pick a third point, and then just get enter, or a fourth point, okay? So what you should notice right now as we look at these objects, there's no way to tell the difference between the two. They look identical. But if you come up here and you click this object right here, you left click on him, notice only he highlights, but all the other lines don't. If I come down and pick on this object, the whole thing highlights. So this tells me that there's a difference going on there. The other thing is too, you'll notice with the line, you get these blue boxes. These are called grips, okay? And you have what's called an endpoint grip, and a midpoint grip, and another endpoint grip. You basically have the same thing with the polyline, but you also notice your midpoint's a little bit different. Okay, so that kind of shows you that grip is, notice that's more elongated than that one. So that tells you it's a polyline. Okay, from a terminology standpoint, on a line, that's called an endpoint, and that's called an endpoint. Okay, on a polyline, you have a starting endpoint and an ending endpoint, and typically, well, everything really on a polyline is called a vertex. So really this is a starting vertex, and then that's a second vertex, third vertex, and fourth vertex. So the other thing that's unique to polylines is they actually know which direction they're drawn. So they have a starting direction and an ending direction. So this polyline knows it's going from this way to that way. Okay. This line really doesn't know that. I mean, it knows it's two endpoints, but it doesn't know whether that's the start endpoint or the end endpoint. So it doesn't really know that. So there's a bit of a difference. So the polyline has a little bit more, you might think of it as an intelligence kind of thing than not. All right. So that's a little bit of a difference. Okay. So also, I think I showed you, we can take a polyline. If you click on that polyline and you come up here and hit the explode option, it'll make it a non-polyline. So that was a polyline. It's no longer a polyline. It's now a line, line, and line. And I don't know if anybody's thinking about this, but there is a way to go the other way. So if I have 3 lines, it's possible to join those guys together as a polyline. And in fact, the name of the command is join, and we'll be talking about that when we go into the modifies. So you can kind of go both ways with this. Okay. So the polyline is somewhat unique because it has more options. One of the biggest uniquenesses of it is that it can have width. So a line can't have width, where a polyline can. Now there's something newer in AutoCAD. When I say newer, it's probably 20 years old, but it didn't come out initially, and it's called a line weight. So a line weight is a way of making that line more hefty or thicker, if you will. I don't want to use the term thickness because thickness means something else in AutoCAD. Thickness means you're taking that object and you're pulling it out in the Z direction, making it like a panel or a piece of plywood or something. So there's a difference than that. All right, so if you have some objects on screen, let's just go ahead and clean them up because we're going to play with some polylines. So I'm just going to again go into erase and ALL, enter twice. Okay. So polyline has a lot of sub options. So let's go ahead. We're going to grab the polyline command, and the first thing it's going to do is ask me to specify a point. So I'm just going to eyeball a point. So the minute I eyeball a point in there, notice you will automatically now get polyline options. So you have the arc, half width, length, undo, and width. So you are in what's called the line mode of the polyline. If you go to the arc mode, what it'll do is it'll switch you over to the arc options. So basically the arc options we just talked about up here, you're going to have a lot of the same options when you select it down here. Width and half width are essentially the same. It's just the way you're defining the width. So if I use the width option and I say the width is 0.2, that means it's going to be 0.10 on one side and 0.10 on the other. Okay. If I use the half width and I say 0.1, then it means I'm going to get a 0.2 total polyline. So I typically just use the width. So what we're going to do is we're going to go into the width option, and I'm going to make it 0.5. So it's going to ask me a starting width, and then it's going to ask me an ending width. And the reason is you can taper these. So like if you wanted to draw an arrowhead, you could start out with a width of some value, and then you go to an ending width of 0. So I'm going to make my starting width and my ending width the same. So I'm going to just accept that 0.5. And notice now as you draw, go ahead, and if you're following with me, you're putting some lines in. You notice that what you're getting is lines with width. Now you might notice too, this looks pretty nasty right there. It's not like beveled shut. But what will happen is once you put the last point in and then you hit enter, notice how it fixed itself. So it's fixed it nicely right there. Okay, has everybody seen how that works? Exactly the same width option that you were seeing in the rectangle command. It's working similarly in the polyline. The only difference is that you can taper the width when you create polylines, and you can't do that in the rectangle. The rectangle is going to be a constant width for all objects. Okay, is everybody okay with that? And if I pick on this polyline, notice the vertexes are actually embedded in the middle. So there's my vertex, there's my other vertex, vertex, vertex. So again, remember, this corner really doesn't exist. It's just the way it models it to look. All right. So prior to line widths in AutoCAD, if you wanted to have an object that had a width like this was the only way to do it. But since there's other ways to do it now, polylines have kind of, we just don't need to use them as much as anymore as we used to. All right, so let's take a look at a couple other options. One thing, by the way, is once you go into the polyline command and you turn a width on, it stays on. So if you don't want to have a polyline with width, what you would need to do is make sure as you're creating them, you set your width back to 0, and that would give you no width. I'm going to leave my widths on just so we can see them. So I'm going to do another polyline, and I'm going to pick a starting point. And notice it tells me that I've got width on right now, so I'm going to leave it on. I'm just going to pick a second point. So one of the cool options here is this guy called length. And length will allow me to give it a distance. All right, sure. So what I'm going to do is give it a distance here of length, and I'm going to give it a value of, let's say, 3 units. That didn't function right. Something went whack. Let me let me undo that. I think when I went and picked up something on the screen, it changed it. Let me try that again. So I'm going to again go back into my polyline command. I'm going to pick a point. I'm going to pick a second point, and I'm going to go into length. And what it wants to do is know how big my length segment's going to be. So again, I'm going to just type in 3 or 5. And what it does is it knows the direction of the first line segment, so it just shot out another line in the same direction. So that's a quick way of going in the same direction with a line. So if you picked length and then you hit enter now, there's 2 possible scenarios. It took that in point and it pushed it out units, or it actually tacked another segment on there. And if you click on this, you'll notice what it actually did. There was my second point, and when I told it to give it a length, it automatically just pushed that out. So this actually has 2 segments. So if I would explode this polyline, it's going to give me 2 segments back. And interestingly also, if this was my first point and that was my second point, the direction of this polyline is this way. So if you give it a positive distance, it's going to shoot that thing out this way. If you give it a negative distance, it's going to put a line on top of itself going the other way. All right, so there's going to be 180 between each other. That's what's going to happen. So normally, from my standpoint, I guess if I was looking at this, I would essentially say I would pretty much always use positive distances. All right. So another thing that's very important for polylines is what we call closed polylines or open polylines. Okay, so I want to show you what I mean by that. There's a big difference between the two. Okay, so let's go ahead and you might just want to click on your polylines if you're drawing some polylines. And once you selected them, just hit the delete key and that'll take them out. So if you draw a polyline back to the starting point, it doesn't always necessarily make it closed, okay, which is kind of weird. Even though mathematically it might be closed, physically it might be closed, from the database standpoint, it doesn't think it's closed. So I'm going to show you the difference. And when you have width on, you can definitely tell the difference. So what I would like you to do is we're going to go into the polyline command, and we're going to start out at a coordinate like 2, 2. And hopefully you can see it like mine. And I'm going to pull it out. I'm going to do a triangle from here to here. And then I'm going to go back to the starting point. So I'm going to type in 2, 2 and hit enter, and then enter again. All right. So this is a closed, physically closed object because I started and ended at the same coordinate value. Okay. But you'll notice this has a sharp corner, this has a sharp corner, and this doesn't. And the reason is because it thinks, AutoCAD thinks this polyline is open. Okay, so that's what you're referred to as an open polyline. So it doesn't necessarily mean you have to have a physical break. okay? So if I go back into the polyline command and I pick a point, pick another point, pick a third point, notice there's an option there called close. If I close it, this object is now not only physically closed, but from the standpoint of the database and the polyline object, it also thinks that it's closed. Okay, so there's a big difference between these two guys, right? It's subtle, but it actually is there, right? Any questions on that so far? Okay, let's go ahead and show you. You can incorporate arcs into your polylines, and doing arcs are just as difficult as doing arcs other ways, but actually there's some pretty cool stuff, so I'll show you one thing that's neat about it. I'm going to go ahead and just delete these two polylines that I've created, so I'm just going to click on them, and then I'm going to hit delete. So if we go into the polyline command, and we can just pick a point and pick another point, what we can now do is draw a tangent arc right off of this. If we go to the arc option, you're now in an automatic tangent arc option. So if I just define the endpoint and another endpoint and another endpoint and a third endpoint, those guys are all tangent to each other. And if I want to go back and do other things, I mean, I've got angles and center points and all of that. I can use all that. If I go back to the line command, notice that this line is necessarily not tangent. Okay, so there is a way to make it tangent, but just to understand that this guy is not tangent automatically, where the arcs typically will be when you're constructing them. Okay, so again, you're not probably going to use this too much, just because it's so laborious if you're trying to get arcs in any fashion or any valid way. But this is a very useful tool. Let me show you one of the cool things I think about the arc and the arc, polyarc and the polyline, and probably there's really no easy way to do this in AutoCAD other than the way we're going to do that. So what we're going to do is go into the polyline command. We're going to pick a starting point, and we're going to pick an ending point, and then we're going to go into the arc command. So what I'm going to do is I'm going to do what's called a tapered arc here. So I'm going to go into the width option. I'm going to make the starting width 0.5, but I'm going to make the ending width 0. So now when I draw this, and then I hit enter, notice I have this nice tapered look. So I went from a 0.5 width to a 0.5 width here, and then that starts at a 0.5, and then it ends with a 0. That's probably only one way you can do that in AutoCAD if you want that tapered look. So that's kind of cool. All right. We're not going to use polylines a ton. Some people like them because what they do is they keep all your objects together. So that's kind of nice from that standpoint, but it's not necessary for everything we do. Okay. Any questions? Okay, so let's go ahead. We'll clean our screen up, and I'm just gonna do an erase all and enter twice. And you might want to follow if you've been zooming in and out. If you type in Z and hit enter and A, it'll bring you back to your biggest screen that you have. So we're going to take a look at the polygon command. So the polygon is going to generate a 2D P line, and it is what we call a regular polygon. So I'll explain that here in a minute. The polygon command is buried underneath the rectangle command. So if you open up that little drop down arrow, you'll notice there's rectangle on the top, and underneath it is polygon. Okay, so let's go look at this a minute, okay, and show you some things about polygons real quick. Does everybody know what I mean by regular polygon? Does anybody not know what that means? Who can tell me when we have a regular polygon? That's a polygon. Is it regular?
I'm guessing you mean equidistant legs.
Correct. That's exactly what I mean. So this was not a regular polygon. So the type of polygon you're going to get is going to have, it's going to have two things that are equal. Not only will the distance be equal, but all of the angles will be the same inside. Okay. So again, like if you're doing a triangle, okay, you're going to have a triangle that's going to have equal leg, equal leg, equal leg. That's as good as I can do it. So these distances should all be the same, and these angles in here interiorly would also be the same. So that's a regular polygon, okay? This polygon that we create, the polygons will be, as we said, they'll be 2D lines. I forgot to mention, there are two types of polylines. Okay, so there's what you have, we have what's called a 2D, oops, I'm in this mode. We have what's called a 2D line. And we have what's called a 3D line. So in the 2D line, all of your Z values are the same, they're constant. Another way of saying that is that this object is what we call coplanar. A 3D line allows you to draw different Z values on your vertexes. So it can come out of the board. The command that we've been using is actually, if we go back over to here, this command is 2D polyline. I think if you go here underneath there, I think they have it here somewhere. Yeah, it's one of these. There's your 3D command, and that's actually the name of the command is 3D poly. Okay, we're not going to use that. So I just wanted to mention that since I used that term. Okay, so the rectangle or the polygons that we're going to use, dang it, sorry about that. The polygons that we're going to use, they're regular polygons, and they can be anywhere from 3 sides up to a maximum of what? What would be the maximum number of sides you can have on a polygon? Anybody know? Is there a maximum number on the side of polygons?
No.
No, technically there's not, but AutoCAD obviously has a maximum. So essentially you could have an infinite number of sides. So, but AutoCAD does have a maximum. So basically you can go from 3 up to 1024. And that's basically a binary number. I believe that's 2 to the 10th. So you get past about probably 500 sides, and what a polygon starts to look like is a circle. So really this is actually outrageous to go that high, even though that's not that much considering to what it could be. So there's two ways of defining a polygon, what they call an inscribed polygon and a circumscribed. So I'll try to draw this, just it's hard to draw these things. Let's see if I can get a circle here. So you have an imaginary circle that you're going to generate this polygon in. That circle doesn't really exist. So what you're generating is a polygon that's going to look like this. What you're going to define is the center of the circle, and you're going to define the radius to that. So this polygon is inscribed in this circle. The vertexes of that will be just touching that. Okay, that's called an inscribed polygon. The other one they have is what's called a circumscribed. So what you have is, if this is your polygon, I'm going to try to draw this as best I can. This is going to be hard. So what you have is, let's see if I can, yeah, I didn't think that was going to work. Let me see if I can do it this way. You get an imaginary circle inside of this guy. So the circle's imaginary. And what you have, you will define the center of your polygon, and you'll define again the radius the radius in this case goes to a tangent point, and that's actually the midpoint of that distance. So this would be midpoint, 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 midpoint. So this is called an inscribed option. This is a circumscribed about. So those are basically two ways of creating polygons. The third method is what we call an edge method. So I'll show you these. They're pretty simple. So if we go back to AutoCAD, and we go to this guy called your polygon, the first thing it wants to know is the number of sides, okay? I think if you've never used it before, it always shows up with 4. But once you've generated a polygon, it will actually remember them. So unless you want to change that up, it'll keep that number. So let's, we're going to make this maybe a 10-sided. And by the way, that has to be an integer number. So you can't have 10.5 sides, okay? Or something outrageous like that. So I'm going to put 10. And then automatically it asks me to select the center of the polygon or edge. So I'm going to just go ahead and pick a center. And then it says, okay, do you want to be inscribed in a circle or circumscribed about a circle? So notice the default option is inscribed. So if I just hit enter, notice what I'm doing is I'm dragging it out. And remember, you don't see the circle, but the circle is outside of this thing. And what it's asking me to do is to find the radius. And so the radius, that circle would be touching each of the vertexes of that. So if we type in a number like say 5, got a little bit bigger, you don't see the circle, but from the center out to that would have been 5 units. Okay, that's all there is to it. And you'll notice that all the distances, that's the same distance, same distance, same distance. If I would measure that angle, and that angle, and that angle, they're all the same. So it's what we call that regular polygon. And again, if you click on this guy, you'll notice, you know, that's a P line. If you list this thing, if I type in the word list, notice it doesn't tell me it's a polygon. It tells me it's a polyline. And that LW stands for lightweight polyline. And I want you to notice that notice all the vertexes, they're all zeros because they all have to be the same. Okay, so this is your vertex listing. Vertex 1, vertex 2, 3, 4, 5. Okay, everybody get the idea? Pretty simple. Let's try that again using, this time I'm going to use a different method. So I'm going to remember the same sides. I'm going to use the same number of sides. I'm going to pick another center point right next to it. This time I'm going to do what's called a circumscribed. So I'm going to select circumscribed. And notice this time when I drag it out, the circle is embedded inside. And so notice the radius is going to the midpoint of that segment. So if I use the same radius, 5, it might look like they're the same size, but you'll notice if I move the one into the other, you'll notice that the one is slightly bigger than the other because of the way it defined it. Okay, so the distances here will be slightly different than the distances here, but that angle and that angle is going to be the same. Okay, so only thing it does is just kind of scales it up or down, right? So those are the two differences. They're somewhat subtle. And as you get more sides, these kind of objects kind of approach each other. Okay, they kind of are going to be about the same size. If you have less sides, then it'll be a lot further off. Okay, so we're going to use the other option, which is called an edge option. So in this case, if I have a polyline, or let's see, a polygon that I want to draw, and I want to have an exact distance along this, I can do that with edge. So for instance, let's say that we want to generate a triangle. And I want all of these sides to be exactly the same value. And also, I want this guy to be at some angle. So for instance, let's say this is my x-axis. and I want this to be 30 degrees, and I want this to be 5 inches, and that to be 5 inches, and that to be 5 inches. So if I want to do something like that, the edge option is going to be a really, really good option for me. So what I would do is go into polygon. I'm going to use a 3-sided this time. I'm going to use the edge option. So what I do is I pick a first point, and what that does is that like sticks a pin in at that point. So what it wants me to do is to find both the distance and the angle. So by utilizing a relative coordinate, I could say at 5 less than 30. So I'm using a polar coordinate to do this, and I would hit enter. And what that did is this guy is 30 degrees with respect to x, and if I measured these distances, they would all be the same, 5 inches. So there's basically 3 different ways of defining polygons. And again, this is one of those commands that you just don't use a ton of. So, but I think probably I got some assignments we might use this, but not too much. Okay, any questions? No, we're plugging right along, so hopefully you guys are catching all of this. Okay. All right, so I'm going to go ahead. Let's go ahead. If you are following along with me, let's go ahead and we're going to erase things. So I'm just going to erase all, enter twice, and follow that up with a zoom all. Okay. So the next option we're going to take a look at is a little option that's really good for mapping kind of purposes or for other kinds of things. Actually, it's not my favorite anymore because you can't have a lot of different types of them, but the object we're going to look at is called a point. So this is a nice little 2D object, and the point object basically comes in different looks. So you can have it look like a little point, you can have it look like a cross or an X, you can have it with a circle in it. Okay, so the way these look, these are governed by what's called PD mode. That's a setting variable, PD mode. And the size of these guys are determined by a value called PD size. Okay, so that would determine the size of that. And PD size can either be relative to the screen zoom. So as you zoom in and out, what will happen is your points are always going to look the same size as you zoom in and out. If they're relative to the screen zoom, if it's an absolute value of say 1 inch, when you zoom out, your point's going to get smaller, and when you zoom in, it's going to look bigger. So there's kind of 2 ways of doing it. The thing is that if you set your PD mode up to a value, you can't have multiple ones. So it's impossible for me to have that symbol and that symbol in at the same time. That to me is a problem, because if you're doing any kind of mapping, you like these little symbols to represent things. So that might be a ground shot that you've taken, and that might be, let's say, a light pole. They can't do that with this in AutoCAD. I'm not so sure why they don't allow you to do it, but that's always been a downside. We've got a project we're going to do in a couple of weeks where we're going to actually use these little critters. So we're going to see how they work. They're kind of neat. So let's take a look at them. They're really easy to use. First of all, to do the settings on this, we're going to type in a command called dd ptype. Okay, so the command is dd ptype. So go ahead and enter that, and it'll pull up this dialog box. There's another area that you can find this. There's a couple places you can find it, but what we're looking at is the settings that you're going to set for all these points. So notice here's your different styles that you have. These are your PD mode settings. down here, this is your PD size setting. And the way these work, it's kind of weird, but this is called 0, 1, 2, 3, 4, and then it jumps up to 32, 33, 34, 35, 36, and then 64, 65, 66, and then ultimately goes 96, 97, 98, 99, 100. So it's just kind of the way they've set it up. So notice a PD mode style setting of 0 gives you a point. If you put it to 1, you get nothing. Now, that's important to understand, because if you set it to that, you can place points on your drawing. They're just never going to show up. Okay. So what we're going to do is we're going to go to this guy, which actually would be PD mode 0, 1, 2, 3. And we're going to go to the size setting here, and notice this is set to the percentage of the screen. So what we're going to do is set this in absolute units, and I'm going to make this 0.5. And then I'm going to hit OK. So when we create points, then you can either just type in the word point, and it'll allow you to just place that point, and it'll recognize the settings that you used. Or you can come over here, and they have what's called multiple point. Once I gotta find it, I think it's that one right there. So this is going to allow you to generate more than one point. So I can just pick a point, pick another point, pick another point, pick another point. Okay. And really, that's all there is to it. They're just more or less markers. Think of them as markers. That's probably the best way to define these guys and think about them. Notice then, because I'm still in that command, if I want to get out of there, I just hit enter, or actually I have to escape in this case, and that terminates it. So again, because these are absolute sizes, if you zoom in with your mouse wheel, notice they're going to get bigger. And if I zoom out, they're going to get smaller. If you set them to a percentage of the zoom scale factor, they'll always, when you zoom in or out, they'll always look like they're the same size. Okay, so I don't normally do it that way. All right, so I want to show you if we change the PD mode setting. So let's go into PD mode. I'm sorry, yeah. Let's go to DDP type. DDP type, because that one's a little bit easier. If I change that to one of these other values, such as that guy right there, and I hit OK, it's going to automatically change all of the points in my drawing to the same style. So I really have no control over that, other than I can have one or the other, but not both. And again, I have a real problem with that, because, like I said, as a mapper, I like to have different symbols, so this isn't really highly useful to me. Okay, but I'll show you some things about points. We're going to utilize these in an assignment, I think the 4th assignment. Okay, any questions? By the way, these cannot be exploded, so you can't break this down into something lesser than what it already is. So if I hit that and hit explode, it does nothing. Okay, it'll say that was not able to be exploded. So you can't break that apart. I mean, the only thing you can do is either change the PD mode setting, or you can just delete it. All right, so we're going to just go ahead and get rid of them. So if you would just do an erase for me, erase all, enter twice. Okay, so we got one more to talk about. We're going to look at a command called the donut command. And this also happens to be a polyline. So a lot of things are kind of unique in AutoCAD. They're polylines. But what the donut does is it generates basically a 2D filled in polyline. So you're going to have one here, and then you're going to have one here. So it's not perfect, but I think that's pretty close. I think you get the idea. I kind of call it a washer. These will be concentric, so they're going to have the same point, unlike that I drew it. I can't draw it that well on here. So what you're going to define is what's called an outside diameter on this guy. Okay, so you'll define an outside diameter, and then you're going to define an inside diameter. And once you do that with the donut, then you just place the center point. And what it's going to do is generate those. If you have this filled on, then you're going to see this filled in here. All right, so the name of the command is donut. Okay, and we're going to go over here. So we find the donut command here, and it's down at the bottom row there. So when you select that, it'll ask you for the inside diameter first. So it's got a value in there of a half a unit. If you want to just go ahead and accept it, just go ahead and hit the enter key. And then your outside diameter is defined next. So obviously your inside diameter has to be less than your outside diameter, or this guy doesn't work. So I'm going to go ahead and accept that outside diameter of 1. And notice then you just place donuts. And as you place them, notice I like to, instead of a donut, I kind of think that they're a washer. But and when you're done, you can just hit enter. So they're not, again, super useful, but there is one really cool thing about them I'll show you here in a minute. But I don't do these kind of objects too often. And keep in mind, because this is a polyline that has fill line or width, this edge really doesn't exist. So if you're trying to make this edge tangent to a line, that's gonna take some work. You can't just do it really easily. If you click on this donut, you'll notice you actually have 2 arcs that create this 2 poly arcs. So one arc goes from that one to that grip, and then the other arc goes from here to here. And if I would explode this, you'll notice there's your one arc and there's your other arc. Okay, so it's actually somewhat complex in the way it's constructed. Okay. So the other thing that's really good about donuts, and this is what I use them for the most, is if you wanted to generate a solid circle. Prior to hatch patterns in AutoCAD, one of the only ways you could actually generate donuts that are, excuse me, circles that were filled in was to do it with a donut. Now you can do it another way, but this is still a good method. So what we're going to do is we're going to go into the donut command. What you do is you set your inside diameter to 0. Okay, so I'm going to set my inside diameter to 0. Leave your outside diameter to a value greater than 0. And when you place your donut, notice what you're getting are solided circles. Okay, and that's what I use the donut to do this type of structure more than I do that. But I mean, they're both useful, just depending on what you're doing. But again, just depends. Okay, so those are the draw commands that we're going to look at. Now let's see, we should be done by 5 here. So basically, I'm done. I do want to go over a couple things, and then I'll get you out of here. One is, I didn't show you this, but what governs the fill-in look on a polyline is a command called fill. So generate, if you will, go ahead and just generate a polyline for me too. And let's give it some width. Let's make it a width of maybe a 1/2 inch and a 1/2 inch. So notice if you draw a polyline like that, go ahead and hit enter. These are all polylines, by the way, okay? And they all have fill looks to them. So if you don't want these to be filled in, what you can do is turn the fills off. So the command to do that is called fill, F-I-L-L, and hit enter. And notice currently your fill is turned on. If you turn that off, what you do is notice is that your screen isn't changing. So we have to follow that up with what we call a regeneration. Okay, so you just type in RE and hit enter. And that's what a non-filled polyline will look like. Notice they look quite different, particularly arcs. Arcs look a little bit different than, say, the straight lines. So that's your polyline with width. That's your polyline with width. But remember, they're donuts. Now, one of the things about AutoCAD when you plot, and we'll be talking about, I'm going to go plotting. I'm going to show you guys how to plot on Wednesday. Primarily, I want us to work for drawing, but I do need to show you how to plot. So if you plot this picture right now, AutoCAD is what you call WYSIWYG, so what you see is what you get on the paper. So if I would print this picture out right now, this is what it's going to look like. It's going to have this spoke look to it. So if I don't want that, I have to go back into my fills. So I type in fill and set that back to an on state, and then I have to regenerate it like that. And so that would print that exactly the way you see it there. All right, I know we covered a lot. We're gonna have this guy saved for you, and then I'll have this formatted. So if you have any questions, you know, you can also ask me, but that's covered a lot of ground today. So let me go to Blackboard real quick and show you some things you want to look at. Okay. The first thing is under weeks. All right. You should have the 2 folders open now. Okay. Week one, there's the commands. We finished this off. We started it last week and finished this. There is this sample coordinate input sheet that you had, so that's available. This is your week 1 assignment. So this assignment right here, I'm going to just open this up. This isn't available to you guys yet, but I'll make this available as soon as we get done here. So what we're going to draw on this is a pretty simple little drawing, except it's going to, some of you are going to probably sail through this and some of you probably will not. So it's going to take us a little bit of time, but we'll have basically the whole period on Wednesday to work on this. So this is going to primarily focus in on using the line, the arc, the circle, and the rectangle commands. And the primary function on this is just go ahead and deal with coordinate systems. The picture that we're going to draw is this picture right here, except you are not going to be drawing the dimensions. You're going to be utilizing these dimensions to construct this. So I'll be going over this with you on Wednesday. I mean, if you want to get started playing with this, be my guest. That won't be a problem at all. The directions are, I mean, I think they're easy to follow, but if you're not real sure about some things, keep in mind you can't do anything wrong. Okay, that's the bottom line in AutoCAD. You may not get it to work for you, but you can't do anything wrong or you can't mess up anything. So what I would suggest is maybe just play with it. If you got to the point you could print this out today and play with it, this would be great. What we're going to do though is first is set limits up. Then we're going to create a rectangle for this exterior border. Then we're going to go in and generate these lines. Then ultimately we're going to establish, we got a coordinate here. We're going to work around this figure like that, place some circles and place a square. Okay, so that's what we're going to be doing on Wednesday. So I got this up there. I'm going to go ahead and make this available. Under week 2, okay, under week 2, what we just did, we went over the draw commands, P-line, polygon, point, and donut. So we're halfway through. These guys won't take that long. Depending on where you guys get on Wednesday, I probably will not. I'll probably show you how to do the file commands, and I'll also show you how to do plotting. So under this, there's a couple things you might want to print out between now and next week. Or Wednesday, excuse me, there's a print dialog box here. So if you wanted to print this out, this is what it looks like. This shows you the print parameters. And the other thing is this is a screen capture, what the print dialog box looks like. I'll bring a copy of this with me and probably have copies for you. But if you wanted to start looking ahead about this, this is showing you kind of how to print. Printing in AutoCAD's a little tough at first, the first couple of times you do it. Also, I will be posting, this lecture is from last year or last summer. So the lecture we just did, I'm going to be replacing this one with this. So probably in about an hour, this guy will be available to you. And the assignment 2, I'm probably not going to worry with assignment 2. We have to finish assignment 1 first, okay? So that's what we'll be looking at. All right, so does anybody have any questions before we get done here for the day?